Hello everyone, this is Jassim Mutlaq from StellarMate. In this video, we'll be going over the new release StellarMate app version 2.1.0. To use this app, you need to have StellarMate OS version 1.55 or higher, since this app adds quite a few features, including live stacking, which we'll be demoing soon. So I already took the liberty of running the scan, and here I have the Ikarus Spy. Actually, that's the StellarMate connected to my home observatory, as you can see here on the video. And I'll be connecting to it right now. So I'll just go ahead and click on it. And there we go. Now we're connected to the observatory. Here we see the equipment profiles. If you need to set up your drivers to connect to your equipment. And below here, we select the primary scope and optionally the guide scope as well. Let's just go quickly over my equipment just so you expect to see. So for a mount, I have EQ8 mount, and for that I use the EQ mod driver. I have two zoom cameras. I have the Nightcrawler rotator / focuser device. I also have a custom roll-off roof with a custom driver written in ND, and I highly recommend that for those who have roll-off drivers to get it mechanized. It will just make your life a lot easier. I'm also adding flip flat as a dust cover and a flat source, and I have a watchdog driver just to watch in case anything goes wrong. Alright, so let's go ahead and get started. Let's click start. And now Ikarus is supposed to connect to all the devices. Now let's go click on Ikarus. And here we see the new Ikarus interface. The first thing you see here, the image, this is actually a simulation image from my last testing session. So let's start from the top left corner here, where you see a few icons that you might be familiar with, because these are indeed the same icons we use in Ikarus. And we designed this in a way now as to follow logically in the usual astrophotography workflow. So on the left most side, we start with focus. So this is where you're doing your autofocusing, or you can optionally also do manual focusing and focusing using pattern of mask. Here we have the alignment module. This is where we do the capture and solve to solve any images and improve our alignment. Not the poor alignment tool. Actually, the poor alignment tool is going to be re-released again in the next version 2.20 while we work on improving it. But this is for the alignment tool, the regular alignment tool. You can also use load and slew to select any file that you desire and then go to it. Then we have the guiding. This is the internal guide tool that we use in Ikarus. Then finally, so after you focus, align, guide, you start your capture process. So here we have the capture process. The extra two modules is one for the mount. In here you set some limits, and also you set the meridian flip and you configure it. And finally, here we have the Observatory Module, which is for now is primarily used to control any dust cap devices, any domes or roll-off roof. So actually, we'll start here, and I will go ahead and unpark the roll-off roof. All right, so it is over right now, and I need to unpark the dust cap. Here it shows unparked, but actually this is not correct, and it's not a driver problem. There is a mechanical issue in the dust cap itself that reports this value. So let's go ahead and try that again, and there we go. We see it now unparking. All right, so now let's talk a little bit about the three other controls here on the right-hand side. So here the T is for the telescope or mount control, and here we see the directional controls on the right side and on the left side of the tablet screen. And at the bottom here, we see the mount speed control and the P for parking. So this is to park and unpark your mount. And the other two controls we'll just go over in a minute. And it's also for finding your targets and also for syncing. All right, so let's start by unparking the mount. So let's just click on the P. So now the mount status is idle. And here at the bottom, you can see the coordinates. So we have the right ascension declination, and then also the horizontal coordinates, azimuth and altitude, along with the pier side. All right, so let's go ahead now and select our target. So let's click here on this icon and select, let's select Messier M42, the Orion Nebula. Let's just type 42. There we go. And then let's just simply click Go To. And so the mount now should be slowing to M42. And here you can see the status at the bottom. So this telescope control is called Quick Control. And so Quick Control is an overlay that you can activate at any time. So see that we go through the various modules and the overlay is always there. Same thing for the camera overlay. So this is the camera overlay here. And then we can activate it anywhere we go. That's why it's called Quick Control. So you can access it at any time. All right, so now let's make use of the camera overlay. So the first icon at the top here, that's for preview. The second one is to loop an image, like so, to capture and loop the image. Third one is for any video, for cameras that support video streaming. And the live button is for live stacking, which we'll be testing shortly. The final icon here on the bottom, the cogwheel icon, is to configure the camera settings. And so this is for quick configuration of the camera setting, like the most camera settings. So we set the type, the exposure, temperature, gain, offset, things of this nature. If you click this little arrow here, you can also select which camera exactly you want to configure. So in our case, we have two cameras here. We have the primary camera and the guide camera. All right, and so let's minimize that and let's just keep everything as is, and let's just click preview. And so this is going to take a few more seconds to show up. And there we go, we have our first image here. And so let's go ahead and run the usual astrophotography workflow starting from the left. So let's go ahead and do focus. So the first thing you would want to do when you have especially new equipment is that you want to select a preset. A preset, as the name suggests, is a collection of settings unique to a camera or filter wheel combination. So let's click plus, and let's say, for example, call it our primary setting, our primary preset. Let's select the focuser as Nightcrawler. The camera is going to be the main camera, exposure 1 second. I'll leave the binning, and gain, I might increase that a little bit. So let me put 357 and let me save that. All right, so now we have our primary preset. And actually that's pretty much what we all need to do. And let's just click autofocus. Of course, you see here all the settings, process, and mechanics. These are all very advanced settings that you need to set. And so there we go. Here we have our selected star, and then we have the autofocus algorithm running right now. It's trying to pinpoint the best focus. All right, so actually we want now autofocus. Now it's back to in focus. All right, so autofocus done, and we have this HFR value. Of course, we can always come back and run this again in the future in case we need to improve the focus. All right, let's go to the next step. Let's do alignment. So we are supposed to be exactly at the center for M42. Again, let's do a preset because each preset is actually different for each module, but this is only need to be done once. So let's call this one align. And if I can spell properly, okay, align 178, for example. So this is the camera, the scope. The camera is set on the primary scope. 10 seconds is sufficient. Maybe I'll increase it a bit more. Pinning is, well, I'll select 2x2. Gain is fine. Accuracy 30 arc seconds. So accuracy is that it needs to iterate until the desired target is within 30 arc seconds of where the telescope is looking at. And so SIP profile is the profile you'd want to use to solve. And this is, you can do it by experimental. Let's just now use the default. That should be good enough. But sometimes, like if you have a wide angle camera, you probably want to use number 3, large scale solving. But for our case, let's just use default. Let's save the setting. And yeah, so now this preset is set, and then it's remembered for next time you run your equipment profile. So you don't need to set it up every time. For the action, we set it slew to target. So what it will do first, it will capture an image, then it will plate solve it. And so plate solving tells us where the mount is really looking at in the night sky. And then, of course, we know where the telescope thinks it is looking at. And then eventually we command the mount to go to the actual center of the target we desire, and then it should be there. And that's usually done through a couple of iterations. All right, let's do that. So let's now capture our first image. All right, so our first image is captured, and now it's being plate solved. All right, so the first plate solving is done. It identified it's really far away. It's about 2,500 arc seconds away from the target. So now it commanded it to move closer, and it's in the process of taking. All right, and we're almost right at the center. Pretty much, I would say we're very close. Yeah. So now you can see here the error at the bottom is 40 arc seconds. You can see other information like the field of view. So it's 28.2 arc minutes times 18.9 arc minutes. You can see the pixel ratio. So it's 1.09. The rotation angle east of north. All right. So we have here notification that the alignment completed successfully. So we're good to go. So now let's go to the next step. So maybe Orion Nebula is not a very good target for guiding per se, because it's actually very bright and you can get very good results in 30 seconds. But let's go ahead and do this. So let's again go ahead and add a preset. Let's call it the 120 preset. And then, so the scope, so I have it on a guide scope. And actually that's not correct. All right. So our guider is the ASI 120. We're going to send the correction pulses directly to the mount. Some folks would use an SE4 cable. That's usually only recommended if your mount does not support guiding. But if it supports guiding, then it's recommended to use it directly. Exposure is 2 seconds. Pinning, I'll keep it 1 by 1. And the rest is okay. So I'll just click save. You will be safe most of the time using the default settings because we just optimize the default settings to work for the majority of the cases. So maybe you can start with the default settings and then adjust accordingly. All right, so now we are in the calibration phase, and this is actually going to take a while the first time it runs. So I'll skip ahead and I'll be back after the calibration is done. All right, so the calibration is complete, and now we are beginning the guiding process. And here you can see the guided drift in arc seconds in both right ascension and declination. In the red line is actually the RMS, or root mean square value of the guiding process. All right, so if we are guiding and we're focused and we're aligned, the next step would be go to capture. And here, same thing again, we add a preset. And this is especially important if you have, different filter settings, different filter wheels. It would be nice to have a preset that you use for a specific configuration or a specific number of settings together. All right, so let me set this up as, let's say, RGB, I guess, because it's an RGB camera. 178. This is going to be, so it's going to be this camera, which is the 178 MC. Type is light, so we have light frame, bias, dark, and flat. The exposure, I'll take 60 seconds. The pinning 1x1 format, I'll leave it as fits. Temperature. All right, so temperature, well, I'll just set it as maybe, let's say, -5. The gain, I'll actually just have no gain, 0, and the offset I'll set as 0 again. So, all right, I think that's good. Let's just save this. And then here I set how many counts I need for this specific configuration, this specific preset. So now for just testing purposes, I will just do 5, no delay, and add to sequence. And here you see all, like what we call a job. So this is a single job. And you can see from the, iconic description here that it's a light frame. It's a 1x1 pinning. It's only goes for 60 seconds. Both the ISO or the gain is 0 and the offset is 0, and it's 0 out of 5 frames captured. All right, so let's just click start, and the first order of the business is to actually set the temperature. So now it's setting it to -5. All right, we got our first image. Let's look at that. There we go. We have this really nice image of the Orion Nebula. And this is a really good time to introduce our next functionality, which is the live stacking. So you don't really need to do much. You just need to press live. And live stacking, as the name suggests, will stack multiple images, and it will try to do automatic background extraction, automatic contrast adjustment. And it just, it's really nice for deep astrophotography targets where, M42 doesn't really need live stacking that much, but for some targets, live stacking would bring up the details and make them much more prominent. And so this is the first image that is taken into account when it comes to live stacking. The next image, we will see the first stacking actually happening. And here you see the automatic background extraction, the local contrast adjustment. But what you will notice more prominently as we capture more frames is the reduction of noise. That's biggest factor in the live stacking, is to reduce the noise to get more clear image, and also to boost the signal of the image without causing saturation, which is a very delicate matter. So now we're going to leave the live stacking to take place while we discover the other features of the app. Now, if we click on the Device tab, we are going to get the system overview, which tells us the utilization in terms of storage, RAM, and CPU of StellarMate. Also give us some useful information, including the IP addresses for the hotspot mode, and also for whether it's connected through Ethernet. In this version also, you have an option of choosing the Wi-Fi band, whether you want to connect through the default 2.4 gigahertz or change maybe to 5 gigahertz band. And 5 gigahertz can be helpful, especially if you have USB 3 devices, because there is actually some radio interference between 2.4 gigahertz and USB 3 that can attenuate the 2.4 gigahertz, but 5 gigahertz is actually immune to this effect. Here we also can change the resolution of the of StellarMate. Check the other information. At the bottom here we see the software, and then we can check if we have any updates, and it also allows us to switch between beta and stable channels. And the beta channel, as the name suggests, is to check the almost daily releases of StellarMate, and it's only recommended if you have issues in some drivers. Otherwise, it's recommended to stay on the stable channel. Up here we have a few icons to shut down StellarMate or restart it. Also to access the web manager and VNC. So let's now try to access VNC actually. It's going to ask us for password, so it's going to be smate by default. There we go. And here you can set some controls, and here we can see the same image we just captured. And here you notice like it looks somewhat better, because here we don't see the compressed version. The compressed version is sent to the app because the app is eventually, it's for viewing purposes. So this is the image that you will see in the in programs like PixInsight and Serial and other on Photoshop. Not the compressed version sent back to the app. All right, let's now go back to the app. Here we have the View tab. So the View tab is where you will see all the images that's captured, either offline, or if you're an Ikarus Live Pro subscriber, then you can see also the images that are stored on the cloud. You can see all the metadata associated with each image, including when it was captured, the type frame, the binning, the temperature, etc. And also you can browse them, filter them through name, either ascending or descending, sort them by ascending or descending characters. Also look at which images were captured at all the time, or just like in the last hour, last 24 hours. There are also more advanced filters, so you can exactly get the right image that you want, even if you have thousands of images. All right, let's go back to Ikarus. And here we see the live stacking process going further. And even if we zoom and compare this, like part of the image, you will see that the noise is significantly reduced and keeps going down with each subsequent image that we capture. And this brings us to the end of this video. Thanks for watching. Cheers and clear skies.